Now let's look at another question. This is a very simple question. You might look at the question. This question might look very lengthy, but it's a very simple question, right? So we can see that. So first of all, we have to find out the equivalent resistance between terminals A and B, right? So we have to find out the resistance between the two. Now, these two resistances are in series, and the combination is parallel to 6 ohm resistance, right? So this is a short circuited path. So we can see that this 3 ohm resistance is also parallel to 6 ohm resistance. This 3 ohm resistance is parallel to 6 ohm resistance. This 6 ohm resistance is parallel to 3 ohm resistance. So if you redraw the circuit, then it will be a very simple circuit. That is one here, 0.8, 3 ohm, 6 ohm, 2 ohm, 6 ohm, 3 ohm, and 2 ohm. Okay, so from where 2 is coming, 1 and 1 are in series, right? So these three resistances are in parallel. Okay. So the resultant will be, and these two also are in parallel. So first of all, let's see what is 6 parallel 3 equal to. So this resultant will be 1, 0.8, A and B. Okay. So 6 and 3 parallel. We know that the result is 6 multiplied by 3 divided by 6 plus 3. That is 2. Right? 6 into 3 is 18. 6 plus 3 is 9. Okay. So this is 2. This is 6 parallel 3 parallel 2. Right? So 6 parallel 3 is 2 ohms. And 2 ohms parallel 1 or 2, sorry, 2 ohms parallel 2 ohms is 1 ohm. So this is 1 ohm. Right? So 6 parallel 3 parallel 2 is equal to question mark. So we know that 6 parallel 3 is equals to 2. So the result is 2 parallel 2, that is 1. Okay. So this circuit is 1, 0.8, 2 and 1 are in series. So this will become 3 ohms, and the result will be 2 ohm parallel with 3 ohms. That is so 3 parallel 2 is 3 multiplied by 2 divided by 3 plus 2. That is 6 divided by 5. That is 1.2 ohms. Right? So R equivalent is series combination of these three circuit resistances. That is 3 ohms. So 3 ohm is the answer. Okay. Right? So now again a very simple question. Okay, very simple question. Let me just now, if you look at the question, then it's a very simple question. Okay, so it is given that R1, we have to find out the power supplied by 25 volt battery. So this is the battery. Now we know that the power supplied is equal to current multiplied by voltage. Okay, and since the battery is providing power, so the current will always leave from the positive terminal. Okay, will always leave from the positive terminal. Okay, so if you do not know the concept, this concept, just I am repeating that concept. So whenever any source is delivering power, then current will leave from the positive terminal. Okay, just remember that. Power supplied means current is leaving from the positive terminal. And if you look at the resistance, in resistance the current always enter from the positive terminal and leave from the negative terminal. So whenever a substance, or we can say that whenever an element in the circuit is absorbing power, then current will always enter through the positive terminal. And whenever any element is delivering power, then the current will leave from the positive terminal. Okay, so this is the concept, and we'll be looking at more concepts in the lecture series of networks, right? It will be an upcoming series that will be uploaded soon. Okay, so now, so we have to find the current I. Okay, so we have to find current I. A very simple KCL at this node will tell you that the incoming current from left is I, from right is 0.4 I, and the outgoing current is 14 amperes. So the KCL at node A will solve the whole question. Okay, so incoming current I plus 0.4 I, and the outgoing current is 14 amperes. So I is equal to 10 amperes. Okay, now the power supplied is equal to current multiplied by voltage, that is 250 watt is the power supplied, right? Okay, so this finishes my question number 6. Now question number 7, a very good question that has been asked by GATE in previous year. A very conceptual question. Looking at the question, it seems that the question is very lengthy, but if you look at the question, then you will find that there is a trick in the question. So now let's look at the question. So it is given that VA minus VB is 6 volt. VC minus VD is to be found out. That is the question. And this is the figure. Now, a very conceptual question. Okay. We all study KCL. Moreover, we know that in the whole question we have to find VC minus VD. That's a question mark. But the very important point is the resistance value is unknown, that is R is not given to us. The only part of the question that is given to us is this part, the center part. Okay, so you can think that this is the kind of hint given by GATE to the students so that they can catch that there is a trick in the question, right? So sometimes GATE used to do this kind of thing also. So if you look at the question, you can see that the value of R is not given to us. So in any way, this portion and this portion is of no use, or I can say that these two portions will not help me in finding the solution because R is not known to me, right? So now let me tell you the concept behind the question. The concept is simple KCL. Now generally by every faculty or every material available, the KCL is always taught at a node. But KCL means incoming current is equal to outgoing current. Okay, so this is applicable at a node also. That is, if we have a node, then incoming current is equal to outgoing current. So I have a node and many branches are connected to it, so I can easily find KCL. Similarly, it is at the system level also. That is, for example, if I have a system, okay, with the two terminals, for example, there are two terminals A and B. So if any current IA enters through terminal A into the system, then the same current will have to leave from terminal B. Okay, so I'm taking only two connections available with the system A and B, okay, to the external world. Okay, so if IA current enters through terminal A, IA has to leave through terminal B. Okay, this is what KCL at the system level. Okay, the incoming current always has to be equal to the outgoing current or vice versa. Okay, so that's what KCL. Okay, it is applicable at the node, it is applicable at the system level also. So let me add a page here. Okay, so okay, so this is the concept that is applied here, and you will be surprised to know that this question was asked in GATE 2012 or I think 11, somewhere around that. The same concept was repeated in GATE 2016 or 17 again. So the previous year are most important. Okay, so this concept is being applied in this question, that is, if any current, for example, this is your node B, this is your node D, this is your node A, this is your node C. Any current that enters this portion of the system, that is this portion, the right part of the circuit, then the same current has to leave this portion through terminal B. Okay, same is the case with A and C also. So let me do it separately. So the concept is, we have to find VC minus VD. That's the question. And one more information is given to me, that VA minus VB is 6. VA minus VB is 6 volt. So the current here is 3 ampere. Okay. So in this portion, the left part of the circuit, 3 amperes enter. So 3 ampere has to leave through terminal C or node C. Okay, 3 ampere has to leave. Now since 3 ampere is coming at this node and 2 ampere is going here, so 1 ampere will go at the top, right? So again I will show you by zooming it. Okay, so 3 ampere is coming, 2 ampere will go here, and 1 ampere will go at the top, right? Now this 1 ampere will flow through 1 ohm resistance and it will create a voltage drop of 1 volt, and it will come back, 2 ampere will come here and 3 ampere will go here. Okay, so we can see that VC minus VD is the voltage drop between the two terminals C and D, and that is equals to the voltage drop across this resistance, 1 ohm resistance, and that is 1 volt. Okay, so the answer is 1 volt. Okay, so the concept here is, the KCL is the simple concept that is applicable in the question, but the KCL here is not at the node level, rather at the system level, okay, or the circuit level, I can say that.